Hello, here I have a Kriesler 11.7 valve radio made in Australia, and I just want to show something regarding the output valve here. That's the output valve, the second valve. Okay, so that's the output valve there. It's a 6V6 GT, and that's the rectifying valve, okay? Now, I'm gonna measure the temperature, is what it's running right now. It's actually running the radio, you can hear it working. All the capacitors have been changed, and now it's running a test. So now, I'm gonna check the temperature of this valve. Okay, and just looking if this focuses, stupid phone, it's running around 124 degrees right at the top of the valve. Okay, the radio has been running for about 15 minutes, so it's pretty much has stabilized at that temperature, right? So if I move that there, it's around 124, maybe 25, 125 maybe, I don't know. And that's the hottest valve in all the other valves. You can see this valve here, it's only running 46, let's say 50 degrees, okay, for the sake of it. That one is running just a bit over 50 degrees. Okay, and there, of course, they're the IF valves and preamps and all this stuff, stages. That's the first IF valve, which it runs pretty cool, right? Only like around 57, 58 degrees, okay? So they're probably around that too there. Now this valve, how I said, the output audio valve is the one that's going to run the hottest. So just do another measurement on it again, and it's running around, how I said, 125 degrees, 126, okay, 126 degrees. Depends where this thing's aiming at, the angle. Now I'll switch that off, this off. Okay, so we know it's running at 126 degrees now. This valve on the original circuit, pin number 8, which is the cathode, okay, looking at the circuit diagram, that's the valve here. The cathode, now pin number 8, goes to ground. Focus, focus. Okay, pin number 8 on the 6V6 goes to ground. Now, on some other models, they actually normally, and even if you look at circuits for this valve, they would have a resistor going from pin 8 to ground, maybe 150 ohms, 250 ohms, right? I put a 180 ohm resistor, so I cut the ground from pin 8 and I put a resistor in series with the cathode, okay? And before, when I measured the plate current, it was measuring around 40 milliamps, okay? Now it's running about 30 milliamps. So with that resistor, the 180 ohm resistor, it's cutting about 10 milliamps. Now, when I had it running on the original circuit, this valve was running hotter. So what I'm going to do, I'm going to switch it off, and I'm going to remove the resistor and have it back how the original circuit is, and then we'll measure the temperature again. Okay? Okay, so as you can see here, that's the resistor, the 180 ohm resistor, that I've put in series with the cathode, okay, on pin number 8. So now I'm going to bypass this resistor by having a bridge there with the alligator clips to have it straight to ground again, okay? And I'll put the whole radio back down slowly, okay, make sure that nothing is going to short out. And then we'll see. And the reason why I didn't want to test it in that way, because when you have this on standing up on an angle, if it's vertical, then this rectifier valve, the heat going up, is going to heat up this valve even more because it's picking up the heat of this valve, being this on top, okay? So best to have it horizontal, so the heat just rises up. So this valve doesn't inherit the heat of this valve. So we can get a better result. So we go back down here, and that's my power supply, which I'm doing some modifications to it, the Variac, okay. So because I just did that just to make sure there's no problem, so I put the dim bulb there, okay, and we'll put the voltage up slowly, and 162 volts there, okay. You go up, let it warm up, and we'll see what will happen. We see how much higher the temperature is going to be. So the radio is working, okay. Okay, so we can take the dim bulb off, and it's drawing around. Even this I cut down the current because it draws less current now. Okay, so I'll let it warm up, pause it, let it warm up, and then I'll measure the temperature. Okay, so let me put the volume a bit down. Okay, now also the current, right? It's running around what does that say? So I can't see. 0.196 milliamp. What am I saying? Amps. 197 milliamps. And you can see that's saying just under 200. Very close. 195, 197, whatever. Okay. Now before I had it running at I think 170 maybe, or I sort of forgot. 175 milliamps. So that resistor does make a difference even in total power, of course, of the whole radio. Okay, that we're running here. So now let's measure the temperature. The radio has been running for about 10 minutes, so we can say it's have stabilized. So let's check the temperature here. Okay, and let me point it exactly on top of the valve, and it's reading around 142. Let's get this right. You can see around 142 degrees Celsius. So how much was it before? 125, 126 degrees, and I was running for much longer. So you can see that the temperature have increased a lot on the valve, which is around 142 degrees, or maybe it might even be 143 degrees. Okay, so almost if it, let's say, was 125, 135, that's 10 degrees. Okay, 140 is 15. and we're reading about 143, I said, 142, 142, okay. It's almost 18, 17 or 18 degrees, maybe we can even say 20 degrees less with the resistor, okay? So there, it's reading. If you look the other temperatures that the scanner is doing. Okay. Anyway, so we can see we cut at least 18 degrees less. And that's a lot. Okay, so that having a resistor on some of, like the other, some of these 11.7 have the resistor. And it could be even a bit higher than what I put. Maybe I can even try a 200 ohm resistor or 250 ohm resistor instead of the 180. Okay. Because I have cut the temperature down by at least 18. Let's point this properly. Okay, about 18 degrees less. Okay, so that was a bad move on Kriesler back then. They keep changing the circuits around, and they decided, just to save a resistor, okay, is to increase the valve temperature. Okay, so just to be moderate, at least, it's actually more, 15 degrees higher on the valve, which to me, 15 degrees is a lot of difference and makes a difference to the valve being wearing out. So that temperature definitely will wear out, so the valve quicker. In actual fact, this is another valve that I had to put in because the original valve had a fault in it. And the original valve had a temporary, when it heats up, the plate will cut off and you have to tap the valve, you tap it and it will start working again. And I would say that's because it's always ran hot, too hot. Those extra 15 degrees or 18 degrees, if it was all those years running with those degrees less, the valve would have lasted much longer. So I had to replace this valve. This is a replacement, a good one, but it's not a brand new one. But the rectifier valve was also not good at all, and I bought a new one. Okay, so these two valves have been changed. So you're better off putting the resistor on the cathode on pin 8, not to ground, on the circuit. Okay. And here also, just to show you, this is another circuit diagram. Okay, from Radio Museum. Actually, no, this one I downloaded from Kevin Chant's website. But Radio Museum have the same circuits, exactly the same. You see on here, this is the 11-7A, okay? Same model as mine. And you see, released July 1947. That's how old this radio is. And you can see here they used a 6V6 GT, the same as in my radio that I showed you, the valve, the temperature of the valve. On here they put a resistor and a capacitor there, which is 24 microfarad apparently. And that resistor of 147, they actually put here a 215 ohm resistor, looks like to me there. Okay, but so let's look at another circuit diagram. Okay, because they changed them so much. Now here, this is another one using an EL33A. But these other valves are different again, okay? Like here they used the ECH35. Well, where my one uses the 6SA7 GT. Okay, and on this one they've put a resistor too, and R169 and a capacitor right on the cathode, and R169 is saying to be 175 ohms, and I actually happen to put a 180. Okay, now again, that's the same as what I showed before. Let's go to another circuit diagram for the same model. So many times they changed it, and this one is really similar to what I have, which is they use the 6M5, same valve configuration. Again, pin 8 goes to ground. Well, the cathode goes to ground. No, I don't know on the 6M5 if that's a pin 8, but okay, with no resistor. Now, this radio that I have has this type of circuit diagram, because this again was another modification that they did. Okay, yeah, so definitely mine one is like that, and that was an EL33A, but the circuit, but the actual valve is a 6V6 GT. Okay, but I will be putting the resistors up. Well, I've already did that and showed you. So, but yeah, they had a lot of versions, and I reckon that they forgot, not unless that was modified, they forgot to put the resistor, or they've ran it like that. Well, it definitely was like that. And as I showed as well, that that modification on mine, which is in the bottom here, doesn't show the resistor, and that's how this one was wired.